Okay, let us start with three-dimensional geometry, some problems today. I'm picking up some problems which are very basic problems. Let us just try to see whether we are acquainted with these problems or not. That will help you to build a concept. Okay. Find a point on this line at a distance of 3√2 units from this point. Okay. So the given line is this y plus 1, right? So this whole thing we will consider like this as a lambda is a constant. So from here we will be getting x equal to minus 2 plus 3 lambda. You can easily see each fraction you compare with lambda and find what is x. So that will give you the choices of the point lying on the given line. That means if you go on changing this lambda, suppose lambda equal to 1, then you will be getting what? Lambda, if I put 1, then I get x equal to 1, y equal to 1, z equal to 5. That means this 1, 1, 5 will be a point on the line. Similarly, if someone will consider lambda equal to 0, so he will get another point that will be 2, minus 1 and 3 like this. So now I have to look for such a value of lambda for which I get a point and distance of that point from this given point becomes 3√2. Presently I do not know what value of lambda is there, so let me consider this to be say lambda 1, and then my point will be say x1, y1 and z1. For formality I am writing let x1, y1, z1 be the point on the line such that let me name it as A, and this suppose given point is named as B, such that AB equal to how much? 3√2. Now from here it is very clear, you can use distance formula here once you know this value of x, y and z, right? So this is the equation which we have to use for finding the value of this point, right? Lambda. So now you can see I can say that for some lambda x1 will be equal to minus 2 plus 3 lambda, then y1 will be equal to minus 1 plus 2 lambda, and z1 will be equal to 3 plus 2 lambda. Now this is the point whose distance from this is 3√2 unit. Now make use of distance formula, right? Distance formula, if you use it, what will you get? AB का distance कितना होगा? पहले इसको ले लेते हैं, right? This minus 1, how much it will be? This minus 1 will be giving you minus 3 lambda whole square. Then next this thing minus 2, so what will I get? Minus 3 plus 2 lambda whole square, and then this minus 3, so what will I get? 2 lambda whole square, and this whole thing equal to the roots of the will be here 3√2. Now I think you people can do it easily, because all that you need to do here is now the simplification. Okay? All of you know the formula a minus b whole square, and then you can easily square both the sides and you can get what is lambda. And then once you arrive at a value of lambda, put it here, right? Then you will be getting the value of x1, y1 and z1, and that is nothing but the record point what they are asking. I hope it is clear to all of you. Thank you. Now come to the next problem. This problem I personally tell you that very important, so please mark it in a very different way and try to understand the concept behind it. Find the foot of the perpendicular from this point drawn to this line. So for that we are going to draw a rough figure. This is the line, right? This line's equation is this. Now we can easily identify that this 10, minus 4 and minus 11 are the direction ratios, right? Direction ratios of this particular line. I think you can remember easily. Now this is the point 2, minus 1, 5, from which if you draw a perpendicular to this line, then it will meet the line at some point. Suppose this is named as A and this is as P. They are asking you to find this particular point. So we have considered the foot as alpha, beta, gamma as its coordinate, right? Our main task is to find what is alpha, beta and gamma. Now very clearly, see, most of the thing I am explaining in the figure, you have to convert this into statement to save the time. Now this line is very clearly perpendicular to this line. So I can find a relation between the direction ratios of this line and this line. This line's direction cosines, direction ratios already I have. Now make use of these 2 points to find the direction ratios of this particular line AP. What it will be? Alpha minus 2, then beta minus 1, that is beta plus 1, and then gamma minus 5. Why is it so? Because we have got one theorem earlier that if x1, y1, z1 and x2, y2, z2 are 2 distinct points, then the direction ratios, one of the direction ratio of joining that 2 points will be given by x2 minus x1, y2 minus y1 and z2 minus z1. The same thing we have used it. Now according to question, okay, these things you have to elaborate before you start with this particular step. According to question, this particular line is perpendicular to this given line 1. In that case, component wise sum of the product of their direction ratios will be 0, algebraic sum, right? So this is suppose A1, this is B1, this is C1, this is A2, B2, C2. If these are perpendicular, then A1, A2 plus B1, B2 plus C1, C2 must be equal to 0. Am I clear enough to understand this so far? I hope there is no doubt right at this moment to clarify. Okay, so this is what you got, one relation. So here you will be getting alpha, beta, gamma, etc. some relations, right? Let me solve it for simplify it for you. Okay, then this is minus 11 gamma, and then minus 20, minus 4, minus 24, minus 24 plus 55. Okay, 55 minus 24, how much it is? 31. So that is this side, if you bring it is minus 31. Okay. So now I got a relation involving alpha, beta, gamma. This is the first step we did. Also, like the previous problem, just what we did, any point on this line can be of the form this, right? X will be equal to 11 plus 10 lambda. How did we get it? Please recall, we have equated. Okay, we have equated the whole fractions, each fractions of the line with lambda, and then we find the general form of the point on this line. So this is the required form of any point lying on the line. Now in particular, if you observe, see, P is also lying on this line only. So there must be corresponding to this point a value of lambda for which alpha will be equal to this, right? Alpha will be equal to 11 plus 10 lambda, and then beta will be equal to minus 2 minus 4 lambda, and gamma will be equal to minus 11 minus 8 minus 11 lambda. If you are having any doubt, to make it little distinct, you could use lambda 1 also, there is no problem. Now all these three you put it here because this is already a pre-existing result. Once you put this value, then this equation star will help you to find the value of lambda. And now easily you can identify, if once you get the value of lambda, putting again here, you will be able to find what are the values of alpha, beta and gamma, and that in turns give you the foot of the perpendicular. Please review the video many times if you are unable to get the concept, but I'm sure you will be getting it after twice or thrice attempts, right? Okay, thank you. Let us start with yet another important problem of 3 dimension, so that the lines this and this are intersecting. Find a point of intersection. There are two parts. You first make sure they are intersecting, and then you find the point of intersections. There are many ways, many options to target the points. You have two options presently. Let me try to tell you. I'll try to take the other option, right? You first see whether these lines are parallel or not. Are they parallel? To check the parallel, we have to only see whether these portions are parallel or not. This is a vector b1 if you compare with the standard form. This is the vector b2. Now if these two are parallel, then the whole lines are parallel, right? And two vectors are parallel once their components are proportional. But very clearly you can see that it is the first components are having ratio 1:3, second is having 1:1, third is having 1:3. That means ratios are not equal, so they are not parallel, very sure. That means these two lines are not parallel. Now not parallel line in 3 dimension may intersect, may not intersect, right? Because we have the concept of skew lines. So to make sure that they are intersecting, all that you have to prove now is that these two lines are coplanar. If these two lines are coplanar, then what will happen? We have a situation where we get two lines in the same plane but not parallel, and then obviously if they are not parallel, they will be intersecting. So that is a way of proving that they are intersecting. This is one way of proving. Second way of proving is that if two lines intersects, then the shortest distance between them will be always 0. So you can easily find the shortest distance between them, and you can make sure that it comes 0. And if it is coming 0, it means the line has to meet somewhere. So we'll proceed with this particular concept. So I'll be using the first case, because in both the cases you need to use the same set of formula. Coplanarity also is the numerator of the shortest distance, so it's all the same, right? So here you have to make little formality. I just speak this formality. Like this line, if you compare with the standard form, you can write vector a1 will be equal to 3i cap plus 2j cap minus 4k cap, and then b1 vector is I cap plus 2j cap plus 2k cap. Similarly, a2 you can consider for the other line, that is 5i cap minus 2j cap. Okay, 0 k cap, 0 is not there, k cap is not there, so you introduce 0. Then this is 3i cap plus 2j cap plus 6k cap. Okay. So first of all you must write, right? First of all you must write clearly b1 is not equal to lambda times, or say some other you use, because lambda is already in use. say lambda 1. This is not like this, which imply b1 is not parallel to b2. Also a2 minus a1 dot b1 cross b2 now will be working out. So now directly you can correlate. So after so much of practices, you can easily identify that this I can write directly now. A2 minus A1 will be the first row here. A2 minus A1, so it is 2 here, component 5 minus 2. Then this is minus 4 and this is plus 4. Then B1 cross B2, so B will be the B's component will be the second row. B1's, that is 1, 2 and 2, and then last one is 3, 2 and 6. Now you have to get a result here 0, right? You should get a 0 here. So I'm just explaining it so that you can be confident. So 2, it is 12 minus 4. 12 minus 4 gives you 8. Then this is plus 4. I am expanding with first row, so it is 6 minus 6 giving you 0. Then last it is 4, so it is 2. It 4 times 2 minus 6. 2 minus 6 means minus 4. So this is plus 16 and this is minus 16 giving you 0. So once you get this product 0, you just see and try to recall that this is the condition of coplanarity. So this will tell you that B1 and B2, and so line 1, later I like line 1 and line 2 are coplanar, right? They are coplanar. They are coplanar. At the same time, plus not parallel. So what should it imply? Intersecting. Okay, intersecting. So we have done up to the first part. Intersecting तक हमने कर लिया. Now you have to find what is the point of intersection. तो point of intersection क्या है? I should get some value of lambda and mu such that if I put those values here in both the places, R will be equal, same. So that means मुझे अभी वो दोनों value निकाल के बताना है. Whatever I put for lambda and mu here, they will generate the same vector, position vector, right? So for that, obviously, it means there are some values of lambda and mu for which this R is equal to this R. So for finding the point of intersection, what I'll write? For intersection point, I'm apologizing for my handwriting. For intersection point, what will happen? I component of this will be equal to I component of this. So what shall I get? 3 plus lambda 1 hoga na, and that must be equal to 5, and what is the I component here? Plus 3 mu. So it is one of the equation you obtained, right? And then you compare with J. If you compare the J component, you will be getting this as 2 plus 2 lambda, and that will be equal to minus 2 plus 2 mu, number 2. And then third one more equation you will be getting, that is here it is minus 4 plus 2 lambda equal to, it will be 0 for k. You can see there is no k component. It will be mu, that is 6 mu. Now the rest of the part I am not going to do. Please listen carefully and try to do it yourself. You have got now 3 linear equations in mu and lambda. Any 2 of them you solve it. Class 10 method, already you know how to solve it. Supposing that you solve these 2, so they will give you some values of lambda and mu, right? But now right at this moment, do not make sure that these are the values which are required, because you have another equation left. Once you solve these 2, you obtain some values of lambda and mu, and then you try to see whether that value of lambda and mu satisfies this or not. If those values satisfy this, इसका मतलब है lambda and mu are those common value for which you will be getting the same point lying on these two lines, means that is a common point. So once you obtain lambda and mu and you are making sure that they are the required value, you go back to the original equation and you put lambda here and mu here, and you will find that r equal to same for both, and that is nothing but the required intersection point. Hope you will understand. Welcome again. You are now again getting one very important question. We did it just before a few minutes, or you can say in the slide 1 or video 1, which was for a line, okay? Image for a line. Now they are asking you image for the point with reference to a plane, okay? So very clearly let me try to draw the figure. You check, you have to find the image of this point with respect to this behaving like a plane mirror. So this is the equation. See, all these you have to write in a formal way. Again, I'd like to request you to make this formal whenever you answer it. I am writing here only. So what should you write? You should write it like this, that the given equation of the plane is this, and equation number 1. Now again I would like to remind you, moment you consider the equation of the plane, always you make sure that there is a perpendicular to the plane whose direction cosines, or rather I say direction ratios, are 2, -1 and 1. So what will be the direction ratios of this line? One of the direction ratio is this, because this I have to use, right? This I have to use. Rather you can say this is that vector only, 2i cap minus j cap plus k cap, if you are considering the vector form. Now this is the point whose image is needed, right? I am writing in the vector form. Say this is the point I cap plus 3j cap plus 4k cap. I need the image of this, right? I need the image of this. Let me change the color, it is looking dull. So I need the image of this point. If I drop a perpendicular, supposing that it intersects the plane, it intersects the plane at point say P, and then obviously if this plane is to work or behave like a plane mirror, then if this is the original point A, its image A dash, then there is very important observation we can make, that AP must be equal to A dash P. What is the reason? Plane mirror always creates images which are at the same distance as that of the original object. That means this will work as the middle point. ठीक है? Okay, इसके बारे में बाद में सोचते हैं. For a moment, if I need the coordinate of this, I can consider its position vector to be say r equal to, कोई भी पकड़ लेते हैं, ठीक है? अल्फा I cap, बीटा J cap and gamma K cap. ठीक है? If you are not finding very comfortable with vector, make it Cartesian, alpha comma beta comma gamma. ठीक है? I'm doing it in the vector form. Please tell if you are finding problem with this, then I'll show you the Cartesian form as well. So very well we have identified, ठीक है? We have identified that, okay, sorry, we have identified that P is the middle point. So we can find its coordinate. There is a position vector. Let me name the position vector as P. Okay, let me apologize. It should not be R. It should be given in accordance with this. So let me use vector B for it, right? Vector B for the position vector of the image. So now as P is the middle point, so you can easily find what is the coordinate, or rather you can say position vector of P. It is simply position vector of A plus position vector of A dash divided by 2, right? So it is I cap plus alpha cap. What you will get? Alpha plus I cap then it is beta plus 3 j cap, and then gamma plus 4 k cap whole thing divided by 2. It is a middle point formula. ठीक है? So we got the position vector of the middle point. We need it because we have to use this point in the plane, because this is the point which is lying in the plane. This is one of the part, right? So because that will give us a link, a relation of alpha, beta and gamma. So now what I can say, P lies on, rather instead of writing vector I can write it as a point, right? P lies on plane 1. Therefore P will satisfy this. That means R के जगह में तुम P बैठा सकते हो. You can put P in place of R because it will satisfy. हो गया? अब इसमें से P बैठा दो, then डॉट प्रोडक्ट तो निकालना आता ही है, डॉट प्रोडक्ट निकाल लो, ठीक है? तो कंपोनेंट वाइज मल्टीप्लाई होगा. इसका कंपोनेंट क्या है? अल्फा प्लस 1/2. इसका है 2. मल्टीप्लाई करने से क्या होगा? अल्फा प्लस 1 हो जाएगा, ठीक है? देन ये माइनस आएगा. देन इसका कंपोनेंट 1 है, इसका कंपोनेंट है बीटा प्लस 3/2. फिर इसका 1 है और इसका गामा प्लस 4/2, राइट? और ये प्लस 3 यहाँ पे ऑलरेडी है. So you can see here that now you are going to get a very good relation of alpha, beta, gamma. I am doing this simplification for you in a short way, so you just take your time to complete this, okay? But you do it, right? Okay, twice alpha minus beta plus gamma, and then here I'll be getting 2, right? This 2 is positive, then this 4 is positive. 2 plus 4 is 6. 6 minus 3 is 3, and then this 3 will again make it 6. So this is the another equation where you will be getting the value means relation of alpha, beta, gamma. I need this. ये एक हो गया. अब next moment में जाओ कि whenever you are trying to find the image, ये वाला जो line है, this line is perpendicular to the plane. ऑलरेडी तुम्हें एक लाइन का प्लेन का परपेंडिकुलर मिल चुका है जिसका डायरेक्शन रेशियोज ये है, या फिर यू इन अ वेक्टर फॉर्म यू कैन डायरेक्टली से दैट दिस वेक्टर इज परपेंडिकुलर टू द प्लेन. इन अदर वर्ड्स योर क्लोज ऑब्जर्वेशन वुड से कि ये वेक्टर और ये जो वेक्टर है लाइन, दे आर पैरेलल. अगर ये दोनों पैरेलल होता है देन व्हाट वी कैन से अबाउट देयर डायरेक्शन रेशियोज, दे आर प्रोपोर्शनल. So can you tell me what are the direction ratios of this line AA or other vector? So direction ratios कितना होगा? Direction ratios आराम से निकाल सकते हो, या फिर rather you can say as you are doing in the vector form, I'll do it in the vector form only. Okay, vector A dash is parallel to vector 2 I cap minus j cap. This तो दो वेक्टर पैरेलल होने से होता क्या है, इनका कंपोनेंट्स प्रोपोर्शनल होता है. तो ए डेस का कंपोनेंट क्या होगा? अल्फा माइनस 1, और प्रोपोर्शनल किसके साथ होगा? इसके साथ, ठीक है? देन सेकेंड कंपोनेंट विल बी बीटा माइनस 3, ठीक है? बीटा माइनस 3 किसके साथ? -1 के साथ. गामा -4 किसके साथ? 1 के साथ, क्योंकि इसका कंपोनेंट 1 है. एंड ऑल दीज विल कंसिडर एज लैम्डा बिकॉज सो फॉर वी हैवंट यूज्ड लैम्डा एनीवेयर. तो फ्रॉम हियर व्हाट विल आई गेट? अल्फा मिलेगा, बीटा मिलेगा एंड गामा मिलेगा इन टर्म्स ऑफ लैम्डा. आई एम नॉट डूइंग इट, राइट? आई एम नॉट डूइंग इट. मेक श्योर कि तुमको ईच ऑफ द फ्रैक्शंस यू इक्वल विथ लैम्डा एंड देन ऑब्टेन व्हाट इज अल्फा इन टर्म्स ऑफ लैम्डा, बीटा इन टर्म्स ऑफ लैम्डा, गामा इन टर्म्स ऑफ लैम्डा. ये मिल जाने के बाद यू पुट दिस वैल्यू इन इक्वेशन 1, तो ये पूरा इक्वेशन लैम्डा में आ जाएगा, ठीक है? तो यू विल बी गेटिंग द वैल्यू ऑफ लैम्डा. और जब लैम्डा मिल जाता है तो इस इक्वेशन से अल्फा बीटा का वैल्यू मिल जाएगा. दैट मीन्स यू विल बी गेटिंग द पोजिशन वेक्टर ऑफ द इमेज. See, it is very easy, it is not difficult. Only thing you have to remember is that the middle point is lying on the plane, and plane doesn't have any normal direction cosine or direction ratio to itself. Its equation only tells us a very specific line which is perpendicular to the plane. इसका फायदा लेना, that's all. ठीक है, thank you. Okay, so today we will again start with some problems of three-dimensional geometry. These are very important problems, so you just try to see. This may be of great work for your exam. Find the angle between the lines whose direction cosines are related by the relations L plus M plus N equal to 0 and L square plus M square plus N square equal to 0. ठीक है, दो ऐसा लाइन है जिसका डायरेक्शन रेशियोज या फिर कोसाइन ऐसे रिलेटेड है. You have to find the angle between them. So once you will be able to determine what are the direction cosines or ratio, anyone, you'll be able to find the equation very clearly, right? So our target is to find what are the individual direction cosines or direction ratios of the given lines. ठीक है, so for that it is very simple. You have to solve this equation and that equation. Only thing is that while solving, this is the skill. So I'm explaining it, just try to see. If any problem you get, just review the video many times, you will understand the concept very clearly. ठीक है? So for doing this, let me start with this equation. Any one of the equation you can start with, but you try to see which seems to be little easier. It is L square plus M square plus N square. Sorry, this is not plus, this is minus N square is equal to 0. Okay. Now we have to solve this. For that, from this equation I can express L equal to minus of M plus N, and this value I'll put it here. Then if I put it here, I'll be getting this as M square, then plus 2mn, M square minus N square equal to 0. N square and N square will get cut, so you'll be getting this as 2m square, 2mn equal to 0. Then 2 can be cut and m can be taken common, so you'll be getting this as m plus n equal to 0. Giving you two options for m equal to 0 or m equal to minus n. These are two options which will generate us two different sets of direction ratios for the line. So now I'll discuss with case 1. Case 1, I'll consider m equal to 0. If m equal to 0, you put it here. What will get? L equal to minus n. Sorry, this is n. L equal to minus n. Now you can see I'm going to get the first set of direction ratios. L is expressed in terms of minus n. What is the next? This is 0. What about n? N is n itself. I mean to say the first set of direction ratios can be considered as L1 equal to minus n, M1 equal to 0, right, and N1 equal to n itself. And because direction ratios are proportional to each other for a given line, instead of considering these as the direction ratios for the first line, we would consider the reduced number when I divide or I take n common, right? So I am left out with minus 1 for this. This is 1 and this is 1. This is 0 and this is 1. That means roughly I'll consider L1 as minus 1, M1 as 0, N1 as 1. So I got the first set's direction ratios as please try to make sure I am still not saying their direction cosines, even if they are given as a direction cosines in the equation. It is immaterial because you have the formula available for both, right? So you find only direction ratios, it will do. So from case 1 I got the direction ratios of the first line as -1, 0 and 1. Now discuss case 2. Case 2 is giving you what? M equal to minus n. So what is L equals? L will be equal to, you put M equal to minus n. So L will be equal to what? 0. What is M equal to? M is equal to minus n. What is n equal to? N is n only. So here I'll consider these as the direction ratio of the another line. So here also in the similar way I can say that they are proportional to 0, -1 and 1. So in that way I can consider the direction ratio of the second line to be 0, -1 and 1. Now once you get these values and that values, easily you can make use of the formula which will give the angle between the two lines with these at the direction ratios. Now if you would like to follow the direction cosines instruction, you can convert them into direction cosine and you can find angle, but I am not going to do so. It is not required at all. So what will be the angle given by? Cos theta will be given by what? A1 A2, can you remember? So here it is L1 L2. I am doing the direct calculations. You saw the formula in the exam if it comes. So L1 L2 will be 0, M1 M2 will be 0, and then N1 N2 will be equal to 1. Then here it is L1 square plus M1 square plus N1 square. So that leads you to root 2 directly I am doing, and here also it is root 2. So ultimately if you multiply root 2 into root 2, you will be arriving at what? Cos theta equal to half. So what is theta equal to? Cos inverse of half, leaving you with pi by 3. So angle between the lines is pi by 3. Okay, just see, many problems of this kind will be there. I'll upload through assignments. Welcome back again. Let us start with question number 6, another important question for three-dimensional maths, three-dimensional geometry. The question has been placed differently or maybe complicatedly, but the question is very easy. So they're asking these lines, okay, these together make a line, and I should have written it very well, and the other, these two will represent another line. Okay? So these two lines are perpendicular if A dash plus C dash plus 1 equal to 0. It seems to be difficult, but once we do it, it will be easier for you. This is X. Sorry, let me correct it. So the first line is X equal to AY plus B, and here Z equal to CY plus D. Both are planes. Two planes writing together represent a line because they intersect in a line. So from here you see what is a common variable. Y is a common variable, no? So you express Y from these two. What you will get is X minus B divided by A, and here you will be getting this as Z minus D divided by C. Now overall these two, if you write in the form of symmetric form of line, then this can be written like this, right? Now modification you make, because y should be written like this: y minus 0 divided by 1, z minus d divided by c. So this is line 1. Now in the same idea, if you write the another equation, you see there is only differences of the symbol a dash, b dash, etc. So here you could directly write the equation in the symmetric form. So it will be x minus b dash divided by a dash, y minus 0 divided by 1, and z minus d dash divided by c dash. This is the another line. Now if two lines you have and they are saying that they are perpendicular, what is the condition? Component wise, the algebraic sum of the product of the components of the direction ratios is equal to 0. That means a dash plus 1 into 1 plus c dash is equal to 0. And now you see your result is very clear. Now it's a very easy problem. People might feel कि ये difficult है, but it's not. Now let us come to the another problem. ठीक है? Hope you have understood this. See question number 7 now. Find the equation of the plane which is passing through the point 1, 2, 3 and make equal intercepts on the axis. ठीक है? So now let us consider the intercepts to be A and A, because they have told that the intercepts made on the three axes are equal. So I consider A for the first intercept, that is X intercept. It should have been B, but as they have given it to be equal, so we consider it as A. Similarly for the other one. So what is the equation of the plane? X by A plus Y by A plus Z by A is equal to 1. Now if you simplify, your whole plane will reduce to this form. Now according to question, 1 passes through whom? Just see the question. 1 passes through point 1, 2, 3. Now if this plane is passing through this point, it will be satisfying that. So you put the respective values of x, y, z to determine what is A equals. So A equal to 6. So what is the ultimate equation of the plane? This is equal to x plus y plus z equal to 6. Great. So I hope you can easily correlate and you can understand this, right? So move on to the next question. This is probably the last question I am doing from 3D presently. This is again an important because it is I cannot remember which year it came, but probably 2016 or 2017 it was there in the board. I'm not sure which year, so I'm not writing. A variable plane which is at a constant distance 3p from the origin cuts the coordinate axis at points ABC, so that locus of the centroid of the triangle ABC is this. Okay, if you draw roughly this coordinate axis, then suppose this is the plane, like plane will be extended, so they have cut the three coordinate axes at points A, B and C, right? Now if the plane is cutting the coordinate axis at points, so their coordinate must be of this form, because this coordinate will be lying on x-axis. Secondly, the point lying on b-axis can be considered as 0, b, 0, and this will be 0, 0, c, right? Moreover, from here it is very clear that the equation of the plane can be written in the intercept form as x by a plus y by b plus z by c equal to 1. This is number 1. Let us keep it ready. This is the equation of the plane in intercept form. But just try to remember that these numbers you have introduced from your side. So this should not be there in the answer. Okay, that's what it can be seen, right? Equation of the plane. My equation of the plane seems to be this, but if I can determine what is ABC, then I am done with the result, right? Okay, now if we have the vertices as this, what is the coordinate of the centroid of the triangle ABC? It will be this plus this by 3, that is nothing but a by 3, another will be b by 3 and c by 3, right? Now let me start with the question again. You see, centroid I got. Now this is a centroid, means it is lying on the plane, right? If it is lying on the plane, it is going to satisfy this particular condition, the variable plane which is at a constant distance of 3p from the origin, right? Am I clear to you? They are saying that the distance of the plane from the origin is 3p. So what will be the distance of this plane from origin? That is 0 0. So use the distance formula. 3p is equal to, origin से डिस्टेंस कैसे निकालेंगे? 0 0 0 पुट करेंगे और यहाँ पे जस्ट ट्राई टू रिमेंबर द फॉर्मूला. यहाँ -1 होगा and here what will I find? It is coefficient of x whole square, coefficient of y whole square plus coefficient of z whole square. Now what will I find here? You see, I can take the reciprocal and I can square to remove this. So I'll be getting this as 3p whole square equal to 1 by a square plus 1 by b square plus 1 by c square. This is one of the result you obtained. Okay, this is one of the result you obtained. Okay. Now what you need to replace? You have to remove ABC. Once you will be able to remove ABC, so you are done with the results. Okay. Now how will you remove it? How will you remove it? You see from here, in the meantime, if you try to remember that this is the coordinate of the centroid, this we can name as alpha, beta and gamma, right? And they are asking you to find what is the locus of this. That means we need to find now a relation of alpha, beta, gamma with P. So now from here what you can see, alpha equal to a by 3, beta equal to b by 3 and gamma equal to c by 3. Okay. So now if you compare, what will be the value of a? It is 3 alpha. What is b equals 3 beta, c equal to 3 gamma. Now in this relation you put that value. What will be a square equal to 9 alpha square? This is 9 beta square, 9 gamma square. In the left side it is 9 p square. Now you can see from every part or every term 9 can be cancelled and you will be left out with a relation which is giving you the relation between alpha, beta and gamma. Now just let me try to tell you that whenever you need to find the locus of a particular point, your target is to find a relation involving the coordinate of that point. So here they are asking you to find the locus, right? So locus of whom? This particular point. So I have found a relation here. Now last, to write the locus, you have to replace these coordinates as x, y, z for general equation, right? So you write, therefore required locus is 1 by p square, 1 by x square, 1 by y square and 1 by z square. Great. That's an important problem. Check it. I took a little more time for this problem. Anyway, that's not a problem. See it, go through it and comment.